squared. What does it mean? We've all seen it, we've all heard it, but what does it mean? 3 squared essentially means taking 3 and multiplying it 2 times. And 3 by 3 is just 9. But when it comes to indices, there's more to just 3 squared, 5 cubed, 2 squared. There's more to that. So the essentials are, this big number is called the base. And this tiny number is the index. And with indices, there are 9 rules. There are 9 rules that you must abide by. Say, for example, you're given 2 raised to the power of 4 multiplied by 2 raised to the power of 3. You have to take into account the base numbers always have to be the same. In every single case, if the base numbers are the same, the rules, they're useless. They're inefficient and they don't apply. When the bases are the same and they're multiplying, your answer will have to be the base. But you will take the indices and you will add them. So 4 plus 3 is 7, and that's your answer. So when the base numbers are the same, you take the indices and you add them. Now, for the second rule, say for example, if you have 2 raised to the power of 4 all over 2 raised to the power of 2. Now, in this case, they are dividing. They're not multiplying. So, what you would have to do is firstly check, are the base numbers the same? The base numbers are the same. So, you would take the indices and you would subtract them. So, you would leave the base, and 4 take 2 is 2. And that's the second rule done. Now, for the third one, it's a little more simple. So, say for example you have 2 raised to the power of 4 bracket 3. So, what you would do is you would keep the base, but you would multiply 2 of these. And brackets essentially mean multiplication anyways, so 4 by 3 is 12, and that's your answer. Now for the fourth one, 2 raised to the power of 0, the answer will always be 1. It will always equal to 1. Doesn't matter, I could have 100 raised to the power of 0, and that will still equal to 1. Anything raised to the power of 1 will be 1. And in addition, this is not mentioned in the rules, but this is an indice rule, anything raised to the power of 1 will be the base itself. Because this essentially means 2, well, multiplied only once, so that will just be 2. And that goes for any other number, not just the number 2. Now, for the fifth rule, say for example, if we have 2 raised to the power of minus 3. Now that minus, we don't like it, okay? We don't like a negative indice. So, the way how we would make this a positive is by putting this into a fraction. So, it would be 1 all over 2 raised to the power of 3. And it goes both ways. It works simultaneously. By taking the base, okay, and moving it to as its denominator, this will make the index a positive once it's in the fraction form, and the numerator will always be 1. Say for example, as I said, it works both ways. If I have 1 all over 10 raised to the power of 2, and the question's asking, write this with a negative index, it will be 10 raised to the power of minus 2, because it works both ways. For the sixth rule, example, you have 3x raised to the power of 2. What this basically is that you are taking this 3 and you're squaring it, but you're also taking the x and you're squaring it because it's within the bracket, and the bracket itself is being squared. So 3 squared is equal to 9, as we said, and x squared, well, that's just x squared. Now, but say for example, if you have 3x squared. 3x squared will not apply. Why? Because that squared is only on the x. The x is being multiplied twice, but the 3 is not. Now for the seventh rule, for example, if we have 2 all over 3, and that is all squared. In this case, what you would do, the 2 is being squared, and the 3 is also being squared. Because remember, this is all happening within a fraction. So your answer will be 2 squared, that gives us 4, and 3 squared is equal to 9. Now rules 8 and 9, they quite similar to each other. Well, if I have the indice 3 raised to the power of a half. Indices, we don't like negatives, but we also don't like fractions. The way how we will get rid of this fraction is by putting it in a square root. Firstly, what is a square root? A lot of people actually don't know what is a square root, and we've kind of just been told, like, hey, just do that. But why? What's its purpose? What does it mean? Well, a square root is basically you just asking what number, when squared, will give us the number inside. So, for example, okay, just write another example. If we have the square root of 16, we have to ask ourselves, what number, when squared, will give us 16? Well, that will be 4, because 4 squared is equal to 16, and that's the square root 16, so that's all it essentially means. So, when you're given 3 raised to the power of a half or any other fraction, you will have to simply put the base within the square root, and that's all. But now, for number 9, we kind of drag the 8th rule a little bit on, and this rule is that 3 raised to the power of a third in this case. Okay, so the difference is the denominators. The denominator is 2, so it will be a square root. The denominator here is a 3, so this will be a cube root. And the cube root works the same way as a square root, okay? So we will work this as square root. We'll put the 3 in there. Think of this as like a little chair or something like that. Okay, so you put the denominator, the 3, right here, and you put the base inside. Now, what this means is the same. It corresponds the same as a square root. This means what number cubed will give us the 3, the base in the middle. So another example of this could be the cube root of 216. So how would we do this out? Well, you ask yourself, what number, when cubed, not squared, this is squared, cubing something is its index being 3. So this will mean 3 times 3 times 3. And what is that? That's 27. But anyways, in this case, you're asking yourself, what number when cubed will give us 216? Well, that will be 6. Why? Because 6 cubed is equal to 216. And what I mean by 6 cubed is I'm just doing 6 multiplied by 6 multiplied by 6. And that's 216. First possible question you could be asked is, say for example, if you have something looking like this. 3 raised to the power of 7 multiplied by 3. All over 3 raised to the power of 6. Firstly, how do you go about with this? The first thing you would have to do is deal with the fraction. That's the first thing. Whatever's going on up here, we have to deal with that. If you've noticed, 3 raised to the power of 7 multiplied by 3, this is our first rule. When we have the bases are the same, so you take the indices and you add them, okay? But this looks a little funny because you have the indice of 7, but what about this one? Well, as mentioned, every number is raised to the power of 1. 3, we have the bases. Now, we take the indices, 7 plus 1 is 8. So we have 3, we take the base, and we add the indices, which is 8. Now we can't forget about 3. Now this looks like our other rule, where we have 2 bases dividing. So we take the indices and we subtract. So I'll take the base, and I'll take the indices and subtract for them. So 8 take 6 is 2. And that's my answer. Now say for example, you're given something like this, right? 3 raised to the power of 2x plus 1 is equal to 2 raised to the power of 3. Firstly, we'll notice that the bases aren't the same. So there's nothing really we can do about that. Try and figure out what's going on over here. And with questions like these, it'll usually be asked like solve for x. And we'll have to solve for x. And the way how you will solve for x is by taking the indices and solving for x. So you take 2x plus 1 is equal to 3. And all I'm doing here is I'm taking the indices, I'm leaving the bases alone, and I'm going to solve for x, because there's an equal sign right here. So that's another hint that you have to solve for x. So 2x plus 1 is equal to 3. I'm going to bring the 1 to the other side. So 2x is equal to 3, take 1. So 2x is equal to 2. So x is equal to 2 all over 2, which is x is equal to 1. And that is my answer. So 2 raised to the power of 2x take 2. So we have an unknown value. Since we have an unknown value, we have to immediately consider the fact that we have to solve for x. This is all equal to 16 all over 2 squared. Firstly, what do we do? Now, as said, we always get rid of the fraction first. If we see a fraction in something, we immediately go for it. And the same applies here. But what can we do? Well, 16 all over 2 squared, well, what is there to do? The bases aren't the same. So therefore, we have to make this 16 into the base of 2. How would we do that? Is we simply ask ourselves, how many times the number 2, because that's the base that we want to turn into, how many times does 2 have to be multiplied to get 16? So 2 by 2, well, that's 4, and 4 multiplied by another 2, that's 8. Well, that's not 16, so we'll just add another 2. So 8 multiplied by 2, that's 16. So we got 16. How many 2's did it take us to get to 16? Well, it was 1, 2, 3, 4. So that means 16 is the equivalent of 2 raised to the power of 4. 2 raised to the power of 2x take 2, and mind you, I am not touching this for now. I'm dealing with the fraction first, is equal to 2 raised to the power of 4 all over 2 raised to the power of 2. And now this looks like a very common rule. When there is a fraction and the bases are the same, which we've already succeeded in doing, we take the indices and we subtract. So 2 raised to the power of 2x minus 2 is equal to, so I take the base and I take the indices and I subtract them, which is, I think, the second rule. So we take them away and we raise to the power of 2. Now we have the bases, they're equal to each other, everything is perfect. So now we take the indices and we solve for x. So we'll do it over here. 2x minus 2 is equal to 2. So all I'm doing is I'm taking the indices and I'm solving for x. 2x is equal to minus 2 to the other side, that becomes a positive. 2x is equal to 4, and now x is equal to 4 all over 2, so x is equal to 2.